Hello friends, this is Krishn Mishra here, and today I am going to talk about the NetSim, and this is academic version software, and how to create a internetworking modules and design. We'll learn here, and we'll go to the new. There is a These are the menus options which is available in the NetSims. First one is the simulation, second one is the programming, third one is the basic, fourth one is the utilities, and fifth one is the help. You can get the help from the help menu. And suppose if you want to get the experimental help, already manuals been given here. You can get the ideas about different live exercises in the NetSim. So first I am going to create one internetworking design with the help of this NetSim software. So we'll go to the simulation, then new, then internetwork. Once you will click on internetwork menu, then you will get one environment to design the network, and you can design by yourself. Okay, so how will these are the toolbox which we can use in the to design the network on environment. So we'll click on the node. When we will click on the nodes, the different node devices we can see here: wired node, wireless node, and um, these are the deactivated. We cannot use these devices for these things. So we'll take the wired node. We'll take wired node. We'll drag it off here. Suppose I'm taking 3 nodes. Okay, so these are the 3 wired node. Then we'll take the switch to connect these nodes together. Okay, and then with the help of link we can connect one node to another node. Okay, then we'll take one router. A router will put on the environment. Okay, I'm sorry, only one will be required for this network. Then we'll connect this switch to the router, and router to the another node. So this is our environment. We can change the place of these tools which is being used in the internetworking. And okay, so if we'll click on the these devices, just see a wire node, and already it's given the access 112 or 180 something like that. Right click on there, we can get the property. We can change the node A. We can change the name also here. We'll accept it. Now the node A. Okay, same things. We'll check here. Node B, and we'll accept it. And no, node C. We can rename according to our requirement. Whatever node name we want to give here. See. So we have the 3 nodes, and one switch is connected by this switch D and router E. Okay, so when we'll go on again wired node, these are the different types of menus given here. Global properties, these are the global property. Okay, applications property is disabled for this, and application layer TCP protocol is enabled here. With the help of transport control protocol, we are going to design this network. The network layer IPv4, we are using the internet protocol versions 4 here. And already by default, whenever you will design here what do you say network, automatically by default it will set one default IP address. Suppose we are using this one only, 11.1.1.2. We'll accept it. So same thing we can check here, was the address been allotted for the. So we'll go to the switch here, interface 1 Ethernet, interface 2 interface 3. So there are 3 devices which is connected with the switch. First is the node A, second one is the node B, and third one is the switch. No, not switch. With this switch, wired node A, node B, and router E. These 3 interfaces connected with switch. Fine. So we'll check the router property also. A router's name is this. Then with the router application layer, we are using OSCF routing protocol. Then transport layer, TCP network. Just see here, there is 3 pooling available here. So ICMP 3 routed button interface. There is 2 interface here. One interface is for switch, another interface for node C. So now we are going to design the application. We'll click on the applications menu and drop on the environment. Then we'll go to the property. Applications type CBR, different types of applications type has given here: custom, email, HTTP, video, voice, database, FTP. For which purpose we are going to design our network, we will by default will select the CBR. Then application type 1, here it's given from which source ID, from which source to where we want to transfer our packet. Okay, so suppose from source ID is 1 and destination ID is 3. From this much time it will take, and time is this. By default, whatever is given here, we are selecting that one. Then we'll accept it. We'll see here, we are sending the package from node A to C. So automatically it will show the application 1. We are going to perform this operation, means node A to node C. Okay, then after application will run the simulation. Now the simulation has started running. It is taking some time. Okay, so once the simulations be completed, it will show you the simulations time, amount of time for which the simulation is run, packet transmitted. It is the total number of packet transmitted in the entire network. It is equal to the sum of packet transmitted in all links. Fine. Then packet collide, byte transmitted. It is the total number of byte transmitted in the entire networks. It is equal to the payload transmitted. Overhead transmitted. It is a total overhead transmitted in the entire network in bytes. It is equal to the sum of overhead transmitted in the links. Fine. So these are the metrics we'll get here. So when we'll go to the NetSim analytics, it will show before proceeding for analytics, save the experiment. Then we'll go to the save menu. We'll save this project. We'll give the name lab experiment. Fine. And we are saving in this directory. Okay. Then we'll go to the NetSim analysis. With the help of this, we already selected lab experiment. Inside that, we'll select the matrix test file, and it will show everything. Simulation time was what, packet transmitted how much, everything it will show here. Fine. And then the packet transmitted how much, packet error is how much, packet collide, and everything. Different menu is given here. You can analyze according to your requirement. Then we'll then we'll deselect this. Again we'll open the same network, live experiment configurations file is the XML file. We'll open this network. Okay, then we'll run the simulation again. Fine. Then we'll view the packet animation. In packet animations, how the data is being transferred from node A to node C, it will show everything properly. Just see here, packet node A is sending the packet with the help of TCP request. Okay, and then once the node C is receiving the data, TCP is sending the acknowledgement to the node A, and data is being transferred through switch D, then it's going to the router E, and then data is received by the packet is received by the node C. Doing the same thing in reverse, node C receiving the data, and it is sending the acknowledgement through router E, then and then acknowledgement is going to the switch D, then node A. So this is the things how the network is working here. Fine, you can see the whole animations things. You can increase the speed also. Fine. So with the help of increase also, it will say even you can increase the simulations time also. Once the simulations will complete here. So how fastly you want to see your analysis, everything it will show here. Fine. So this is the experiment related to Internetwork design and the net simulator. So we'll close here, and I think hope you understand properly. And these are the performance metrics. Everything is showing here. Link matrix, queue matrix. When you can see the IP address matrix also here. How many devices are there? There are 5 devices, 3 node, and one router and one switch. So how the data is being transferred, how TTL, total time taken, total time required, and firewall block is there or not. So many things are required. And node E, the network destination is this, network and net mask, okay, is this, go long. So everything, so many details is given here. Routers E, everything is here. OSCF matrix, you can see here, router C matrix, because only the data is being transferred between routers. So this thing has given here. Then ARP matrix, ARP is given. These are the devices. Everything related to ARP request and response is given here. These are the ARP table. What is the microwave? You know very well. ARP means address resolution protocol. Provide the mapping between the IP address and MAC address. MAC address means physical address of the machines. And applications matrix. This thing given here. Hope you understand well. Thank you. Thank you for watching this video.